Okay, so for 3.1, we're talking all about absolute maximums and minimums and relative max and minimums. And we'll also talk about what a critical number is. So before we do too much here, we should kind of get like a visual of what's going on here. So let's say we've got a curve, something like this. And let's give it endpoints instead of arrows for right now. So starts down here, ends up here. Now, what the idea of an absolute maximum is just what it seems. It seems like there would be an absolute maximum right here. And that's exactly true. Absolute maximum is just the absolute highest point on the graph. There's also an absolute minimum right here. Now, this only works if the endpoints are, if they stop there. So, like, if we had basically exact same graph here, but there were arrows off the end, there wouldn't be no absolute maximum. The absolute maximum would be infinity, but when we talk about an absolute maximum or an absolute minimum, you want to actually have a number. So in this case, there is no absolute maximum or minimum on that graph. Whereas here, the absolute minimum is at the lowest most point, and the absolute maximum is at the highest most point. So that's basically the idea between an absolute max and an absolute min. Absolute max, absolute highest value. Absolute min is the absolute minimum, lowest value. When I say value, I'm generally talking about the y value. We're not worried about how far right and left it goes, those are the x values. We're worried about how high up and how low the graph goes. Now, the difference between an absolute max and a relative max or min, also sometimes called a local, is this point down here would be a local or a relative minimum. You're more likely going to see relative than local, but depends on where you're looking. So relative minimum would be down here. And the idea is it's below every point to the right and left of that point. It's kind of a valley. Whereas a relative max is at a peak. So most of that is basically what you expect to see. Now you do have other situations, such as something like this, absolute value graph turned down, where this point up here would be both a relative and absolute max. Now you notice this doesn't have any endpoints. So it's the highest point on the graph, and it also happens to be a relative max because it's above every point around it. However, there is no relative or absolute minimums. This graph goes down forever. So you got to be a little careful about those things. Other things that kind of throw things in the disarray, you can't really have an open endpoint. So something like this would have a absolute minimum, but no absolute maximum. So let's say like this was like 2 on the number line. Well, what would the absolute highest point be? Would it be 2? Well, it's not 2 because 2 is not included. 1.9, 1.99999. So this does not have a relative or absolute max. It does, however, have a relative minimum. So for you to have that maximum, you have to have the point. So vertical asymptotes don't have absolute maxes or relative maxes or mins because there isn't an actual point there. So this is the main idea right here. This picture is really what you want to think about. Relative maximums at hill, relative minimums at valley. Absolute maximums at the highest most point, absolute minimums at the lowest most point. Sometimes these are the same. So like your relative min is sometimes your absolute min, such as like a parabola opening upwards. You have a relative minimum and an absolute minimum. Sometimes your relative and absolute max are the same. It really depends on what you're talking about. Now, one of the things that you're talking about when you talk about relative max or mins is in this situation, we know our slope is 0. Whereas over here, our slope is undefined. And these points that give you either horizontal tangents or undefined tangents, because it's either here or here, it's not a cross. See that? That cross line doesn't really make any sense. To the left it's one thing, and to the right it's something else. It's a cusp, a corner. So a critical number is where one of these relative maxes or minimums is going to kind of occur. And a critical number is defined as where the derivative, first off, has to be a point. So the definition is a little complicated, but the gist of it is it's a point where it's defined. So f of x is continuous at some c, so it has to be there. You can't have an open circle there. And f prime of c either, so the derivative either equals 0, it's horizontal, or you have this corner, and that's where the derivative f prime of c is undefined. So when you're looking for critical numbers, you are either looking for where the first derivative equals 0 or the first derivative is undefined. People forget about this one. They forget about the corner a lot, and they really just focus on relative max and relative mins for nice, smooth, curvy functions. But this comes up a lot, and it comes up a lot in the AP exam because people focus so much on where the derivative equals 0. And the other thing is, it has to be there. You can't have this situation where, well, looks like we're going to have a relative maximum. Oh, but it's not there. It has to be continuous at that. So that's the main idea. So when you want to find a critical number, the first thing you want to do is take your derivative. And however you're going to take your derivative, it really kind of is up to you. You could use the product rule here, but I really wouldn't. I would distribute x to the fourth minus 4x squared, and then use your power rule. So 4x cubed minus 8x. And now, is this derivative going to be undefined anywhere? No, it's a polynomial. So you solve it, you factor it out, take out a 4x, x squared minus 2, and you're going to have critical numbers at f of, not f of x, at x equals 0 and plus or minus 2, root 2, sorry. So those are your critical numbers. Some of them are a little bit trickier to take derivatives, and you can use what you know about absolute value functions, where this is an absolute value shifted 3 to the right. So if I know this point right here is going to be at x equals 3, I know I have a critical point at x equals 3, because that's where my derivative is undefined. If I look at this graph, there's going to be no place where it's horizontal. This is the only value we're really looking at. So that's basically it. You take your derivative if you can, set it equal to 0, undefined. Those are your critical numbers. Or, if you don't really want to take the derivative, you can always look at the original graph and figure out where its derivative would be undefined, the corner, or where it's going to be horizontal if you happen to know what that is. Alright, so let's talk about finding an absolute maximum. So finding an absolute max or min is basically the exact same thing. What you're going to do is first find f prime of x. Take your derivative and set it equal to 0, or f prime of x is undefined. So that's the first thing you're going to do. Take your derivative, find where it's equal to 0, or where it's undefined. The next thing you're going to do, which is a little tricky because later on you're going to learn something called the first derivative test, and you're going to really get caught up in it, and you're going to forget this. This is like one of the first things you learn in this class. Do not forget how to find an absolute max or min. The next thing you have to do is you're going to find f of a, f of any of your critical numbers, and you're also going to have to find f of b. Now when I talk about f of a and f of b, absolute maximum is always on an interval. So when you look at these problems down here, I've got 0 to 5. I've got 0 to 5 in brackets. I've got negative 3 to 2 in brackets. The brackets and parentheses make a little bit of a difference, but it's always on an interval. And the interval that we're going to talk about is generally going to be from A to B with brackets. As you see, some of these might throw in parentheses to throw you off there. So absolute maximum is always on an interval. Relative maximums doesn't really matter. It could be on an interval. It doesn't have to be. So you have to do the 2 endpoints, and you have to do any critical values. Now, I have 3 here, but there may be more than one critical value. And basically, the highest is your max, and the lowest is your min. And when you're talking about this, I'm not talking about f prime of a, f prime of c. I'm talking about f of a, f of c, f of b. So let's see one of those examples here. Now, a couple things that are a little bit weird here. In this case, I have, well, if I think about this logically, I got 2/3 x plus 5/3. I have a line that starts up somewhere between 1 and 2, and it goes, or has 2 over 3. So we're looking at a graph like this, if it would ever draw. And it stops at 5, but it has an open circle here at 5. So no matter what I do, I know I'm going to have a relative minimum at, well, right here, and or not relative, an absolute minimum at 5/3 and no max. If we wanted to do this out formally, find the derivative of prime of x. Okay, well that's 2/3. Find out where it's equal to 0. It doesn't. Find out where it's undefined. It's not undefined. So there are no f of c. There's no critical value. So what we do f of 0. And we really can't do f of 5 because f of 5 doesn't exist. It's not defined at 5. There's no brackets there. So that's why we don't have a maximum. And you really want to look at the graph of this to really get at this. So we have an absolute max, absolute min. Yeah, f of 0 equals 5 over 3. And you just plug in 0 and you get 5 over 3 as the actual answer. Alright, let's look over here at number 12. That's a little bit more direct. And same thing with this one. The only thing that's weird about this is we have a vertical asymptote at 2, which falls in my interval. So that vertical asymptote is really going to throw off there being any maximums. So if you can look at these graphically, you really want to. So your graph is going to look something like this. So there's not going to be an absolute max. What you'd have to figure out is where the absolute minimum is. These are a little bit cheater questions. This is where most of the problems are going to be. So the first thing you're going to do, find f prime of x, which is 2x plus 1, and we find our critical value to be at, so it equals 0, at -half. Okay, you see if you want to. Technically, a lot of times you should have c, but a lot of people just put x. And then all we're going to do, f of -3, f of -half, and f of 2. So we can use our two endpoints, and we can use our critical value. And now from here, you're just going to evaluate. So we've got 9 minus 3 is 6 minus 6, no, it's just 0. Okay, f of a half. Okay, that's a little bit trickier. I got a fourth plus a half minus 6. And it'd be nice if you had the calculator. This is 3/4. So 6 minus 3/4, which would be 5.25, I believe. Oh, negative 5.25. And then f of 2. Okay, plug in 2. 4 plus 2 is 6. Minus 6 is also 0. Okay. So we got two values that are the same. That happens every once in a while. So what that means is this is the lowest value, so this is an absolute min. And if you had to like fully write this out, it would be absolute minimum, where you could write the ordered pair if you'd like to, or if they want the minimum value, this is the value. Ordered pair would be -1/2, comma, -5.25. And as far as the absolute max, you have two absolute maxes. You have absolute max here, and another absolute max here. The absolute maximum value is 0. The reason there's two of them, it just happens to happen twice. So what you basically have going on here is that -1/2, -1, 2, 3, 4, 5, 5.25, you get a parabola. I'm hoping we all realize that this is a parabola. And this is what's going on. So we get the visual. And we're stopping at these 2 points. They're closed circles. Is there a highest point? Well, sure, it's 0. Is there a lowest point? Well, sure, it's -5.25. So there is an absolute maximum, and there is an absolute minimum. The absolute max happens on one of these. Let's say you extended the right to 3. Well, you get this point up here somewhere, and it would be different. And then the absolute max would be up here at 3, comma, whatever this value is, and it wouldn't be over here. So that's the idea.